Hey everyone, this is Minggoy the programmer, and today we're building a real-world CLI tool in Rust. This program monitors a log file and displays updates in the terminal, kind of like a simplified version of tail minus F, but with custom processing. So I'm coding this on Arch Linux using Codium, like the open source version of VS Code, and we'll install the colored crate to make our logs visually clear in the terminal. So this tutorial will cover command line arguments, file I/O, buffering, loops and polling, and using external crates. So in the end, you'll understand how to build your own CLI monitoring tools in Rust. By the way, this tutorial is for beginners, but not absolute beginners. If you have just started learning Rust, I recommend reviewing some basic resources first, especially ownership and borrowing concepts. And during the coding phase, I won't explain everything line by line. We'll first build the program and make sure it works. After that, I'll walk you through the code in detail so you can clearly understand how everything fits together. I find this approach faster and easier to follow because once you see the program working, it's much easier to connect each function to its purpose. Okay guys, so we will start with our actual coding. So to begin with, let's create a Rust project. So we do this by using the command cargo new, the name of the project. Let's name it log spy because we're going to spy logs. And then we go to the project directory and we open our code editor, which is Codium. Okay, so this is the default project. So we have the cargo toml. So this is we were going to have the dependencies. And let's say we have opened our terminal. And let's first add our colored crates. So by the way, crates are like libraries. Okay, so cargo add colored. Okay, let's go back to cargo.toml so you can see that it automatically added the colored crate. So let's begin. So as I've said earlier, I won't be talking a lot because I will explain it after the uh, the the program is running. But I will be explaining some few things every now and then. First, we need to collect the arguments into a vector. So it should be a string. I don't use the autocomplete. I intentionally did not add like the autocomplete because I find it that annoying. It's okay if I'm developing, but for this purposes, I chose not to. So we need to make sure that the user actually added file name. So we're going to okay. Then let's say okay. Let's try this one. Oh, by the way, before we forget, we need to make sure that we import the end library and also the colored. Okay, I will show you what it does for a bit. Say cargo run Okay, as you can see, this is because we did not enter a any parameter or any argument, so it proceeded here. uh, this is the one X. User need to enter a file name. Let's say, for example, we change this, it will become A. So let's go back with X. And let's say, for example, we add a parameter. Let's say test.log. In this case, this will be the file name. So it did not go to this one because the argument is by default. By the way, the argument length by default is 1. So to show you, okay, by the way, this is the standard for debug mode for Rust. Args, let's say, for example, test log. So as you can see, by default, this is the, if you don't enter anything, this will be the first argument, the default, and this one is uh, the second argument. Let's say, for example, we have multiple arguments. We will see something like this, multiple arguments. Okay, now let's move this out. By the way, this std process that exit, it tells the program to not proceed to exit the system. Let's say, for example, one. Let's say, for example, we'll remove this. Even if the argument is less than 2 or we don't enter anything, it will proceed to show this. So for example, we'll remove this one. It still shows this. But if we get this back, we will not see this anymore. So, okay, enough of that. Let's proceed. Then we grab the second argument. So our argument is the file path. Okay, the typo. By the way, guys, if you're a beginner, I strongly discourage you from doing vibe coding. Just do it for fun, but for actual coding, you really need to develop your critical thinking, uh, your coding skills. Don't rely too much on vibe coding. I do vibe coding for fun, but for actual work, I still prefer to really think, to really write it myself because I'm building a mental model of what I'm doing. Okay, let's try this one. Okay, let's say cargo run, let's say test.log. Yes. Okay. As you can see, this green, so it turned to green, and then since we added file path.bold, so the name of the file path is bold. And let's say we're going to add the variable. It's very important. This is going to be our tracker. So by the way, it means mutable because by default, variables in Rust are immutable. So we need to specify the variable as mutable if we want to, during runtime, we want to alter the state or we want to, yeah, change the state basically. So let's do loop. So we need to loop through. So open the file, focus at the of each iteration. Okay, I won't be talking from here now on. Before we run the program. Only after we were able to run the program, so it will be quicker. So the default is info, and we'll just blue. Okay, there's no need for us to bold this one. And let's see if we got everything here. I think we forgot to add red. Let's see how it works. Let's okay. It's dumb. Why did I put that there? Let's do cargo run. User need user need to enter a file name. So let's say test.log watching. So but we have no test.log. So we'll create here. Let's put this in the what I call this the root. We'll create. So we'll put info. This is great info. Let's save this one. But you can see it shows. So for example, test. Okay, so by default, it is info. Let's say for example, we put warn, save, okay. Hmm, should be warn. Oh, it's working. Okay, this is a problem if we remove. There's nothing, but only when we add. Yes. By the way, normally guys, we when we do this, we always usually in actual, we don't edit the log files. It just keeps on adding. So yes, I know kind of not doesn't make any sense, but in reality, log files they just append rather. Okay, so far it's working. We just need to rebuild it to make sure. Okay, we will go through this line by line. Please continue watching. Okay, guys, before we dive into the line by line breakdown, I just want to mention something. Some of you, I believe, may already understand what's going on in this program, especially if you are comfortable already with file IO and loops in Rust. If that is the case, you can skip ahead. No need to finish this video. But if you really want to understand how everything connects, ownership, buffering, byte tracking, and how the loop works, then stick around. I'll break it down in detail. All right. Okay, let's start from the top. So first, we have our use statements here. These are basically bringing things into scope, so we don't have to write long paths every time. So basically, they are imports. If you're using C, Java, Python, these are imports. So first, we go over here, use std env. So this gives us access to command line arguments. So this one, colorize. This comes from the external crate that we installed. As you can see here, when we installed the crate earlier, this is one of the dependencies. So this allows us to color text in the terminal, and we using by using method chaining like dot red, like this one, or dot bold. So example of method chaining is here on red, dot white, dot bold. So and then we have use sadfs. So lets us open files. We have also these two, BufRead and BufReader. So are for buffered file reading. This is important because reading files line by line efficiently requires buffering. So we have to be efficient. And these two as well, these are the sleep and duration. So they are used to so that our loop doesn't run infinitely at full speed and burn the CPU. So as you can see, this duration, we use this so that in the sleep function, it means that every half second or every 500 millisecond, we need to sleep. So it won't just, so we need some interval so that it will not it burn our CPU or tire our CPU. So it has half second break. So, okay, let's go over this. Of course, this is our main function. This is our entry point. And then this part, I've already explained it earlier, but let us review these and args. So returns an iterator, and we call the collect method. So and turn the iterator into a vector of string. So that's the arg. So this is the variable that we use to collect the arguments. Okay, this block of code. So this args.length -2, it means that we are going to check because by default the argument that length args.length is 1. If you don't, let's say you don't enter anything, let's say cargo run. So by default, I think I've already shown that earlier. So this is to check if there's the file name. If not, it will show this user need to enter a file name. Okay, let's just try this one. And then it prints the print line. So the std process that exit actually it stops this from going to this next command. So it basically stops here. It won't proceed here. So the extract file path, this one. So here we borrow the second argument. By the way, this symbol, this and symbol is actually, it means borrowing. We're not cloning it, and we're not passing it on because this in Rust there's this concept of ownership. When you pass this, it means it will be, I mean, the object will be passed to another memory location, and then after it is finished, the memory allocation is deleted. So to understand deeper into ownership and borrowing, I suggest that you read other sources online, or maybe we can make a more in-depth explanation for that. It depends. If it depends. So, okay. So, of course, this is saying that we are watching this file or monitoring this file for any changes. Let's say, for example, test.log. So yeah, it prints if there are already since we have already existing entry on this or logs in this, so it just displays this one. So another line, this let mute last position. So this variable tracks how many bytes we've already read. So instead of rereading the whole file every time, we remember when we stop. So we just start where we left off. So the key idea here is we're basically implementing our own lightweight version of tail minus F. If you're familiar with uh, the Linux command tail minus F, so this is the implementation of that in Rust. And of course, the loop. This is an infinite loop. So as you can see, it doesn't have the conditional. Uh, it has no like. Uh, it runs infinitely because the purpose of this is to keep on checking until as long as the program is running, as long as we don't terminate the program, it will just keep on checking if there are changes in the files. So as I've said earlier, this is like it keeps on looping, but it tells the loop to sleep for at least half a second before uh, it loops again. Okay, so okay, let's go over this one. This is the if this pattern, okay, okay, this you see this okay. I know it's kind of confusing to most. So this is pattern matching, and it returns a result on a result. Okay, if opening succeeds, let's say for example, we have an actual file that is test.log, so it will return this a file. Uh, it will open it will proceed here, but if it fails, it will ignore it for now. So we don't have any, let's say maybe we can have it something like this, but we decided not to. So it will just keep on checking. Yeah, this avoids crashing if the file is temporarily doesn't exist. So and then we move to the next, this one. So the BufReader here wraps the file and adds buffering. And then without it, every read might hit the OS directly. So we need to buffer. So buffering makes line by line reading efficient. So here we skip already read bytes. This moves the file cursor forward by however many times how many bytes we've already processed. So here we cast it as integer 64 because seek relative expects that type. This function expects parameter that is I64 or integer 64, 64-bit integer. So this ensures we only read new content. So this one ensures that we don't read everything from the top, but just the new content. And this line, of course, we create a reusable string buffer. And if we reuse it inside the loop instead of reallocating each time. So it is instead of reallocating, we just put it inside the loop. So this one is for reading the lines. So it it reads into the line and returns the number of bytes read. So if that returns zero, that's like this one, it that means we hit an end of file. Okay, so that's why we break. So and then processing each line. So okay, we pass this as I've said, borrowing. We pass this reference to the line to our helper function. This is our helper function. So again, borrowing, not moving. So here we update its position. So we increment our position tracker. So next iteration, we skip these bytes. So it means that's where we start. That's where we start when on reading, not the entire file. Okay. Line that clear. Of course, we need to clear the line. Instead of creating a new string every time, we reuse the same one. So this is efficient memory usage. So automatic file closing. So we have this okay, once the block ends, the if let block ends, okay, file goes out of scope. So Rust automatically drops it. No manual close required. So this is RAA in action. RAII in action, okay. So the sleep part, I already explained it. So this pauses the loop for half a second. Without this, the loop would run continuously and consume CPU unnecessarily. So here, I think this is already self-explanatory. So if the line is empty, we just ignore it. We skip in everything. We don't even bother to check here. But let's say, for example, there's an entry. It checks if that contains error. Let's try this one. That's why we put here error. If it sees that there's an error word here, of course, it will print this command. And the same with warn. And if there's nothing, just like this one, it would automatically um, identify it as info. So, so overall, so these programs combine CLI arguments like I/O, buffering, looping, ownership, and external crates into one practical tool. And I know this one looks very simple, but it demonstrates several core Rust concepts working together. So I hope you have learned something, and I'll try my best to do this once more, but a very improved version. I hope. Please feel free to comment. Feel free to comment on what I need to improve on my teaching. So, guys, have a great day.